This is part C, all right? So the question is that. Now, the one thing that's different about this is the denominator is not factorised, you see. Okay. Well, when I factorise it, I'm sure you can do it as well, you can see why it's a partial fractions question. But, you know, unless it's actually factorised, you've got to think about that method. So what to do is, when you've got a algebraic fraction, none of these apply to trigonometry, by the way, or exponentials, okay, and the like, because partial fractions about with algebra. So when you've got something like this, where you can factorise the denominator, it's partial fractions. Always partial fractions, okay? So the first thing to do is check to see if you can factorise that, and you get this, okay? Sometimes a question I'm asked is this, so I'll just pose the possibility. Sometimes I get asked the question, isn't that just going to be 2 natural log 1 minus x squared, or something like that? No, it's not. Because look, if you think about it, y equals 2 natural log 1 minus x squared. So differentiate that, you're going to get 2 over 1 minus x squared, aren't you? But then you've got to differentiate the 1 minus x squared. You get negative 2x. So that's going to be multiplied by negative 2x, isn't it? And so, can you see, because there's no x term there? Yeah. And that's the difference, okay? If you had this, you can still use partial fractions, but you can just write the answer quickly as a natural logarithm, okay? But there, it's like that, you can't. So you've got to use the partial fractions method, okay? Hope that made sense to you. Okay. Yeah, right. So I've just put the method on the board again. This is what I do in between these video takes. You see, I just do this. Okay, so hopefully you're happy with that. It's a much simpler one, isn't it? Yeah. Pause the screen if you want and just check it yourself. There you go. So your A is 1, B is 1. It's pretty simple, isn't it? Okay, so you're going to write that integral as 1 over 1 plus x plus 1 over 1 minus x. Aside from, well, actually no, including the fact you've got to factorise this. This is the easiest example so far, isn't it? This is probably the easiest example we've had for a long time. Okay. Did you like all the substitution work? Did you like all the by parts work? Okay. Yeah. So natural log 1 plus x, and then natural log, well, why have I not put a plus or minus? Yeah. 1 minus x, differentiate that, divide by negative 1. Yeah. Those are both natural log terms, so I'm going to write the constant as that, natural log of k. Right? Here we go. And just write this, can you do that? K times this, and then divide by this. So k, 1 plus x, over 1 minus x. Done. Natural log of k, 1 plus x, 1 minus x. Just check again. Okay. I still can't believe I copied that damn thing wrong earlier. Number 2. Okay. Anyway, yeah. I think I ended on a quote, didn't I? Okay. I've got more quotes. Okay.